Good evening. Today we are going to start an important topic, permutations and combinations. Before we actually start permutations and combinations, we have to discuss fundamental principles of counting. Now, the fundamental principles of counting are used to determine the total number of possible outcomes for doing some particular thing. Actually, there are two principles. The first is addition principle and the second is multiplication principle. Can be understood easily. Suppose there are 10 Marathi books and 20 English books. Then a book out of these can be selected in how many ways? Yes, 10 plus 20, that is 30. So here I can say one thing, that is selection of Marathi book, can be done in 10 ways. Another thing, selection of English book can be done in 20 ways. Then total number of ways in which either Marathi or English book can be selected is what? 10 plus 20, that is 30. That is why it is called as addition principle. So I can say that if one thing, THING, if one thing can be done in n different ways and another thing can be done in n different ways, then one of the two things, that is either first or second, can be done in how many ways? M plus n different ways. In short, if the word or is used, you have to add the number. You can extend this to number of things. I'll give another example. Suppose there are 10 boys and 15 girls. Then one boy and one girl can be selected in how many ways? Will you say 10 plus 15? No. Why? Because one boy out of 10 can be selected in 10 ways. And after that, a girl out of 15 can be selected in 15 ways. They say a boy and a girl. So number of ways is 10 into 15, that is 150. So here we have to take the product. Okay. See, the word and is used. And means occurrence of both. I can explain using a different logic. Suppose first boy is selected, then girl can be selected in any 15 ways. So for the first boy, 15 possibilities. Similarly, for the second boy, 15 possibilities. Third boy, 15 possibilities, up to 10, 15. So 15 plus 15 plus 15, 10 times, that is 150. So can I say that if one thing can be done in n ways, and having done it by any one of these n ways, a second thing can be done in n ways, then the total number of ways of doing both the things one after the other is m into n. So if the word and is used, you have to take the product. Of course, we can extend this principle to number of things. Suppose first thing can be done in m ways, second n, third p, then total number of ways in which all the three things can be done one after the other is n into p. Is that clear? Now, in this example of boy and girl, how will you frame the problem so that addition principle can be used? So in that case, we can say that there are 10 boys and 15 girls. A student is to be selected out of these. In how many ways can this be done? So when I say a student, means either a boy or a girl. So total number of ways in that case is 25. Now the result of counting objects, even if we say boys and girls, we say objects in a set, it doesn't depend on the order in which these objects are counted. Okay, or the method used for counting. This is called as invariance principle. Now we are in a position to solve sums from exercise 3.1. First one, a teacher wants to select the class monitor in a class of 30 boys and 20 girls. In how many ways can the monitor be selected if the monitor must be either a boy or a girl? What does this mean? Anyway, so write the solution. A boy out of 30, a boy out of 30 boys, a boy out of 30 boys can be selected in 30 ways. And a girl out of 20 girls in 20 ways. And a girl out of 20 girls in 20 ways. Therefore, by fundamental principle of addition, therefore, by fundamental principle, PRINCIPLE, fundamental principle of addition, the total number of ways a teacher can select a class monitor, equal to 30 plus 20 equal to 50. Okay. Second, a signal is generated from two flags by putting one flag above the other. If four flags of different colors are available, how many different signals can be generated? Don't write, let me explain first. See, four flags of different colors are there. Signal requires use of two flags. Now the first flag can be selected from four flags in how many ways? Four ways. Now selected flag cannot be selected again. So second flag is to be selected from remaining three. This can be done in how many ways? Three ways. So the first flag and second flag, and means product. So what is number of ways? It is nothing but 12. Okay, right up. There are four flags of different colors. See, at least for first few sums, we will write detailed solution. There are four flags of different colors. There are four flags of different colors. Two flags are required for a signal. Two flags are required for the signal. The first flag can be selected in four ways. The first flag can be selected in four ways. Full stop. Second flag is to be selected. Second flag is to be selected from the remaining three flags. from the remaining 3 flags. This can be done in 3 ways. This can be done in 3 ways. Therefore, by fundamental principle of multiplication, by fundamental principle of multiplication, the total number of signals generated equal to, by fundamental principle of multiplication, the total number of signals generated equal to 4 into 3 equal to 12. Most of the students have written correct answer for sum number 3. Let me read the sum. How many 2-letter words can be formed using letters from the word space when repetition of letters, first part is allowed, second part is not allowed? First I'll explain and then I'll dictate. See, there are how many? 5 distinct letters in the word space. Now, first letter can be selected in 5 ways. Now, repetition is allowed. So, the second letter can also be selected in 5 ways. Note that it is a 2-letter word. So, first letter and second letter. So, 5 into 5, that is 25. Okay. Now, in the second part, they say repetition is not allowed. The first letter can be selected in 5 ways. The selected letter is to be kept aside. Second letter is to be selected from the remaining 4. This can be done in 4 ways. So first letter or second? No, first and second, because it's a 2-letter word. So first letter can be selected in 5 ways and second in 4 ways. So 5 into 4, that is 20. Right now, I'll dictate the solution. There are 5 distinct letters in the word space. There are 5 distinct letters in the word space. We have to form a 2-letter word. We have to form a 2-letter word. First letter can be, next line, first letter can be chosen in 5 ways. First letter can be chosen in 5 ways. Next line, number 1. As repetition is allowed, repetition is allowed, repetition, as repetition is allowed, second letter can also be chosen. Second letter can also be chosen in 5 ways. Second letter can also be chosen in 5 ways. Therefore, total number of words equal to, actually we should say by fundamental principle of counting or multiplication, we are just saying, therefore total number of words equal to 5 into 5 equal to 25. Next line, number 2. as repetition is not allowed, as repetition is not allowed, second letter can be chosen in 4 ways. Second letter can be chosen in 4 ways. Therefore, total number of words equal to 5 into 4 equal to 20. Just listen to me, but please do write the solution after the lecture. How many 3-digit numbers can be formed from the digits 0, 1, 3, 5, 6? If repetitions of digits are allowed, not allowed. You have to be very careful if one of the digits given equal to 0. Why? Because will you say that not 7 is a 3-digit number? No, it is just 1-digit number. Okay. So when I say 3-digit number, 0 cannot occur in hundreds place in a 3-digit number. Okay. See, a 3-digit number has 3 places: units, tens and hundreds, which from left to right are hundreds place, tens place and units place. 0 cannot be in hundreds place. Hence, hundreds place can be filled by any one of the 4 non-zero digits. In how many ways? 4 ways. See, in hundreds place, we cannot write 0, but we can write 1, 3, 5 or 6. Okay. So hundreds place can be filled in 4 ways. Since repetition of digits is allowed, tens place can be filled in how many ways? 5 ways. Why? Because we can write 0 in tens place, no problem. So tens place in 5 ways, units place can also be filled in 5 ways. Now a 3-digit number is formed. Rather, when 3-digit number is to be formed, we have to fill in hundreds and tens and units place. So the word and is there. If you say either hundreds place or tens or units, it will not do. You won't get 3-digit number. So hundreds place and tens place and units place. Okay. So by fundamental principle of multiplication, total number of 3-digit numbers is 4 into 5 into 5. That is 100. This is the first part. Second, now we consider the case when repetition of digits is not allowed. As before, the hundreds place can be filled in 4 ways. After filling the hundreds place, we have now 4 digits. Why? Because initially there were 5. 1 is already used. So 4 digits for filling the tens place. So tens place can be filled in how many ways? 4 ways. Now repetition is not allowed. So units place can be filled in 3 ways only. So by the fundamental principle of multiplication, total number of 3-digit numbers is 4 into 4 into 3. That is 48. I repeat second part. Actually, 5 digits are given, which includes 0. 0 cannot occur in hundreds place in a 3-digit number. So this place in 4 ways. So out of 5, 1 is utilized. Repetition is not allowed. So tens place in 4 ways. So out of 5, 2 are utilized. So 3 are left. So units place in 3 ways. Hundreds and tens and units. So total number is 48. Fifth one, how many 3-digit numbers can be formed using the digits 2, 3, 4, 5, 6 if digits can be repeated? We are given 5 digits which do not include 0 and repetition is allowed. So each of the 3 places can be filled in 5 ways. So number of 3-digit numbers equal to 5 into 5 into 5, that is 125. Sum number 6. A letter lock contains 3 rings, each ring containing 5 different letters. Determine the maximum number of false trials that can be made before the lock is opened. Good one. Let me explain. Don't write. See, there are 3 rings, each containing 5 different letters. So each ring can be adjusted in 5 different ways. Okay. So by fundamental principle, 3 rings can be added in how many ways? 5 into 5 into 5, that is 125 ways. Now, out of these 125 trials, only one trial is successful to open the lock, right? So what is the maximum number of false trials? It is 125 minus 1, that is 124. I will read the sum once again. A letter lock contains 3 rings, each ring containing 5 different letters. Determine the maximum number of false trials that can be made before the lock is opened. Write the solution. A letter lock contains 3 rings. A letter lock contains 3 rings, each containing 5 different letters, each containing 5 different letters. Therefore, these rings can be arranged. These rings can be arranged in 5 into 5 into 5 equal to 125 ways. Out of these 125 trials, only one is successful in opening the lock. Only one is successful in opening the lock. Hence, the maximum number of false trials equal to 125 minus 1 equal to 124. Seventh, in a test, 5 questions are to be are of form state true or false. No student has got all answers correct. Also, the answer of every student is different. Find the number of students appeared for the test. Let me explain. True, false questions can be answered in 2 ways, either true or false. Now, first can be answered in 2 ways. Second can also be answered in 2 ways. Third 2 ways, fourth 2 ways, fifth 2 ways. Now, why product? Because all the 5 are to be answered. First and second and third and fourth and fifth. That is why total number of different possibilities of answers is 2 raised to 5, that is 32. Now, out of these possibilities, or you may call sequences, only one is correct. And they say that no student has written all correct answers. So the maximum number of students in the class must be 32 minus 1, that is 31. I'll explain this part once again. See, true or false question can be answered in 2 ways, either by making it true or false. Each of 5 questions can be answered in 2 different ways. So total number of different ways of answering, or you may call sequences of answers, 32. Out of these, one sequence is of correct answers, but no student has written all correct answers. Hence, the maximum number of students in the class must be 32 minus 1. that is 30. Write down. Write down. True or false questions can be answered in two ways. True or false questions can be answered in two ways. There are 5 questions. There are 5 questions. Therefore, total number of different sequences of answers, total number of different sequences of answers equal to, see on the screen, 2 into 2 into 2 into 2 into 2 equal to 32. Of these, one sequence is of correct answers. Of these, one sequence is of correct answers. And no student has written all correct answers. No student has written all correct answers. Therefore, maximum number of students in the class equal to 32 minus 1 equal to 31. Sum number 8. How many numbers between 100 and 1000 have 4 in the units place? Okay, this is good one. Will you try? Type your answer in chat box. Okay. Very good. 3 students have given the correct answer. Yes, correct answer is 90. Okay. Don't write. Let me explain. See, between 100 and 1000 means 3-digit number. Now, to form a 3-digit number, we can use digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Any one of these 10. Now, what is the condition? That there should be 4 in the units place. Do not write. I'll dictate the solution afterwards. So in this process, I explain solution of each sum twice. See, this digit has to be 4 strictly. Means units place can be filled in how many ways? One way. Now, tens place can be filled in how many ways? 10 ways. Now, will you say that in a number, repetition is not allowed? See, is 4 a number? Yes. Okay. Of course, in this case, 4 will not do because 4 is allowed, not 4. Now, can hundreds place be filled in 10 ways? No. Again, 0 is one of the 10 digits. If you say 0, 7, 4, is this a 3-digit number? No, it is a 2-digit number. So by fundamental principle of multiplication, total number is 90. Okay. One student is saying, how can tens place digit be 4? Because 4 should be in units place. Read the problem carefully. How many numbers between 100 and 1000 have 4 in the units place? Have they said only in units place? having 4 only in units place? No. So this is allowed. Okay, right now. Now I'll dictate the solution. Each 3-digit number should have 4 in units place. Each 3-digit number should have 4 in units place. Therefore, should have 4 in units place. Therefore, this place can be filled in one way. This place can be filled in one way. Now, tens place can be filled. Tens place can be filled using any one of the 10 digits. Now, tens place can be filled using any one of the 10 digits in 10 ways. Using any one of the 10 digits in 10 ways. As 0 cannot occur. As 0 cannot occur in hundreds place in a 3-digit number. As 0 cannot occur in hundreds place in a 3-digit number. In a 3-digit number, comma, this place can be filled in 9 ways. This place can be filled in 9 ways. Therefore, by fundamental principle, one into 10 into 9 equal to 90 numbers can be formed. Ninth is good one. How many numbers between 100 and 1000 have the digit 7 exactly once? Write down. Between 100 and 1000, please start writing. Between 100 and 1000, we have all 3-digit numbers. We have all 3-digit numbers. We have all 3-digit numbers. And we can use digits, and we can use digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2 up to 9. Next line. Digit 7 can be placed either in units or tens or hundreds place. Digit 7 can be placed in units or tens or hundreds place. Now, number one, let me explain. Units place digit is 7. So tens place in 9. Why? Because 7 strictly in units place. This is the first case. So tens place in 9 and hundreds place in 8 ways. Why 8? Because 0 cannot be there in hundreds place, and 7 because we have considered in this case that it will be in units place. That is why we are considering 2 more cases, right? So write down. Actually, you have to elaborate this. Of units place digit is 7. So tens place can be filled in 9 ways and hundreds place can be filled in 8 ways. So number of ways is what? 1 into 9 into 8. That is 72. Write down. Same will be for digit 7 in tens place. Write down. Here also number of ways. Let me explain. Units place 9 ways, tens place 1 way, and hundreds place 8 ways. That is 72. So hundreds place digit is 7. So in this case, each of tens and ones place can be filled in 9 ways. Why? Because 0 can occur in tens place and units place also. Okay. So 81 such numbers. Now considering above, total number equal to 72 plus 72 plus 81, 225. Now you may ask me, in the beginning we have taken product. Why not to take product of 72, 72, 81? Some students argue it is a big number. No, that is not the reason. See, the reason is why addition? Because 7 is in units place or tens place or hundreds place, or means addition. Now to get 72, why product? Because number is formed when we fill units and tens and hundreds. That is why product in that case, and in this case sum. How many 4-digit numbers will not exceed 7432 if they are formed using the digits 2, 3, 4, 7 without repetition? See, this is almost an essay. Actually, we can directly say 4 digits are there and 7432 is a 4-digit number. Okay. So how many 4-digit numbers can be formed? Given digits do not include 0. So thousands place in 4 ways, hundreds 3, tens 2, units 1. So 24 numbers. Now, out of these 24 numbers, this is the greatest. See, in descending order digits are there. So this is the greatest. What is asked? How many 4-digit numbers will not exceed 7432? Not a single number out of these will exceed. So 24 numbers will not exceed 743. Okay. See the solution. A 4-digit number has 4 places, which from left to right are thousands place, hundreds place, tens place, and units place. We have to form 4-digit number using the digits 2, 3, 4, 7. Thousands place can be filled in 4 ways by any one of the given 4 digits. See, 0 is not included. So degree of difficulty is reduced. Since repetition of digits is not allowed, the hundreds place can be filled in 3 ways. Then tens place 2 ways and units place 1 way. So by the principle of multiplication, the total number of 4-digit numbers is 24. Now the greatest number from any set of digits is possible when the digits are arranged in decreasing order, descending order. So the greatest number is 7432. So none of the numbers among 24 formed by the digits is possible which will exceed 7432. Hence, the total number of 4-digit numbers not exceeding 7432 formed by the digits 2347 is 24. So that's it for today.